Okay, good day. So I am Mr. Jerry Quintua, and I am assigned for the part of the linear regression report. So this is wait. Okay, so this is the agenda or part of my report regarding the regression. So first one is finding the best fit line in linear regression, and then model performance, and then last one is the assumptions of linear regression. So let's start with finding the best fit line. So as you can see in this slide, there are two diagrams. So we have the positive linear regression and then the linear or negative linear regression. So when we say positive linear regression, it means that if the independent variable increases on the y-axis and then the independent variable increases in the x-axis, it means that such a relationship is termed as find a positive linear relationship. So when we say negative, if the independent variable on the y-axis decreases and then the independent variable on the x-axis is increases, it means then such a relationship is called the negative linear relationship. So that's it. So when working with linear regression, our main goal is to find the best fit line. That means the error between predicted values and actual values should be minimized. So the best fit line will have the least error. So the different values of weights of the coefficient of lines of a sub 0 and a sub 1 gives a different line of regression. So we need to calculate the best values for a sub 0 and a sub 1 to find the best fit line. So to calculate this, we use the cost functions as follows in the next in this slide. So when we say cost function, so the different values for weights or coefficient of lines, a sub 0, a sub 1, gives the different line of regression. And the cost function is used to estimate the values of the coefficient for the best fit line. Cost function optimizes the regression coefficients for weights. So it measures how linear regression is performing. We can use the cost function to find accuracy of the mapping which maps the input variable to the output variable. So this mapping function is also known as hypothesis function. So for the linear regression, we use the what we call mean squared error or MSE. So cost function, which is the average of squared error occurred between the predicted values and actual values. So it can be written as, for the above linear equation, so MSE can be calculated as by using this kind of formula. So where n is the total number of observation, and then y sub 1 is the actual value, and then a sub 1, x sub 1 plus a sub 0 is equals to the predictive value. So the distance between the actual value and predictive value is called residual. So if the observed points are far from the regression line, so then the residual will be high, and so the cost function will high also. So if the scatter points are close to the regression line, then residual will be small and hence the cost function. Okay. For next one, we have the gradient descent. So gradient descent is used to minimize the MSE by calculating the gradient of the cost function. So A regression model uses gradient descent to update the coefficient of the line by reducing the cost function. It is done by a random selection of values of coefficient and then iteratively update the values to reach the minimum cost function. So the goodness of fit determines how the line of regression fits the set of observations. So the process of finding the model or the best model out of various models is called what we call optimization. So it can be achieved by the following method using this method, which is the R-square method. So R-square is a statistical method that determines the goodness of fit. So it measures the strength of the relationship between the dependent and then the independent variable in scale of 0 to 100%. So the high value of R-square determines the less difference between the predictive values and the values and hence represent a good model. So it is also called a coefficient of determination or coefficient of multiple determination. So for multiple regression, it can be calculated by using the below formula, which is R squared is equals to explained variation over total variation. Next. So the assumptions of linear regression. So there are 5 assumptions. We have linear relationship between the features and the target, small or no multicollinearity between the features, homoscedasticity assumption, normal distribution of error terms, and no autocorrelations. So these are some formal checks while building a linear regression model. So which ensures to get the best possible result from the given data set. So when we say linear relationship between the features and the target, so it means we assumes, or the linear regression assumes the linear relationship between the dependent and then the independent variables. So while small or no multicollinearity between the features, so means high correlation between the independent variables. So due to multicollinearity, so it may be difficult to find the true relationship between the predictors and the target values. Or we can say it is difficult to determine which predictor variable is affecting the target variable and which is not. So the model assumes either the little or no multicollinearity between the features or the independent variables. So next, homoscedasticity assumption. So it is a situation when the error term is the same for all the values of the independent variables. So with this, there should be no clear pattern distribution or data in the scatter plot. Next is normal distribution of error terms. So this one. Linear regression assumes that the error term should follow the normal distribution pattern. So if the error terms are not normally distributed, then confidence intervals will become either too wide or too narrow, which may cause difficulties in finding coefficients. So it can be using the QQ plot. If the plot shows a straight line without any deviation, which means the error is normally distributed. The last one is no autocorrelation. So it means the linear model assumes no autocorrelation in error terms. So if there will be any correlation in the error term, then it will drastically reduce the accuracy of the model. So autocorrelation usually occurs if there is dependency between residual errors. So that's it. So thank you. So that's all for my discussion, or part of my discussion in the linear regression. Thank you.